Welcome to physics classes by Inspire Physics. Today we are going to see a few topics for plus one. The chapter is motion in a straight line. So in this chapter we will start with a few graphs. So we have two types of graphs. One is a position time graph and other one is a velocity time graph. We will see these graphs for different situations. So first we will start with the position time graph. In position time graph, if we have a straight line inclined to both the axes, this is a straight line inclined to both the axes. This straight line represents a uniform motion where acceleration will be zero. There is no acceleration, it is having uniform motion, or we can say uniform velocity. If it is a straight line horizontal, it indicates an object at a rest. If it is a vertical straight line, it indicates infinite velocity. If it is an upward opening curve, it indicates positive acceleration. Acceleration is positive. Okay. And if it is a downward opening curve, it indicates negative acceleration. These are the different graphs for position time. Now a velocity time graph. If you have a straight line inclined to both axes, the acceleration will be uniformly accelerated motion. If it is curve upward opening, the acceleration increases. Not a uniform acceleration, it actually increases. If it's a downward opening curve, it indicates acceleration decreases. Horizontal line, it is uniform motion, means velocity will be same. No acceleration, velocity is the same. Then a straight line such that the velocity decreases with the time. The straight line indicates retarded motion, means the retardation. Acceleration is negative here. Okay, acceleration negative. This is acceleration positive, this is acceleration negative. And if it is a vertical line, it indicates what? Infinite acceleration. Here infinite velocity, this one is infinite acceleration. Okay, these are the important graphs. Now we have two more topics today. Next one is, we need to find the equation for distance traveled by a body in nth second. In a particular second, what will be the distance traveled? So we can represent distance traveled by a body in nth second by the symbol s dash n. So to find distance traveled in nth second, what we have to do, we need to find a distance traveled in n seconds, that is Sn, minus distance traveled in n minus 1 seconds, Sn minus Sn minus 1. To find S, we have the equation S is equal to ut plus half at square. Okay. In this, to get Sn, what we will do, instead of t, you will use n. So S dash n is equal to, we need to get Sn. So instead of a t, we will use n. So you will get a un plus half a n square. This is a Sn minus, we need Sn minus 1. Instead of t, we will use n minus 1. That is u into n minus 1 plus half a into n minus 1 the whole square. We need to expand this. So un plus half a n square minus un minus u plus half a into, we need to expand n minus 1 the whole square, that is n square minus 2n plus 1. So removing the bracket, un plus half a n square minus un plus u minus half a n square, minus minus plus 2 cancels, you will get a n. Then we have minus 1 by 2a. 1 by 2a into 1 by 2a minus 1 by 2a. Okay, so we will simplify further. Un cancels, half a n square. What is the remaining term? U plus an minus 1 by 2a. That is u plus a into, we can take n minus 1 by 2. Or u plus, we can take 2 common here, 2 into 2n minus 1. Okay, we can take u is equal to u plus a by 2 into n minus 2n minus 1. So this is the equation for distance travel in nth second. Nth second means distance travel in a particular second, particular time, that is nth second. Okay. Now we'll straight away go to relative velocity. What is the relative velocity? Relative velocity means the velocity of an object, velocity of a moving object with respect to another object. That another object may be at a rest or in motion. We need to compare the velocity of two objects. If you have two objects moving in same direction, so we have object A and B. A moves with a velocity VA and B moves with a velocity VB. the relative velocity of A with respect to B, if they are in straight line, same direction, VAB is equal to, we can say VA minus VB. Equation is VA minus VB. Then in turn opposite, that is VBA. What is VBA? Relative velocity of B with respect to A. What it will be? We will use a VB minus VA. This situation when the objects are traveling in same direction. Now, if any one of them is in opposite direction, we can choose this in opposite direction. A with the velocity VA in forward direction. This is with the backward direction, that is VB. So this will take negative. Because if we take this positive, this should be negative. So what is VAB? VAB is equal to VA minus VB is negative. Negative VB. What will be the equation? VA plus VB. VA plus VB. And what is VBA? VB is already negative. Minus VB minus VA is positive. So it is VA. We can take minus of VB plus VA. So these two are opposite. Same magnitude but opposite direction. So that's about relative velocity. Relative velocity means velocity of an object with respect to another object at rest or motion. You need to compare the velocities of objects. Then you will get relative velocity. Okay. Now we will see what is meant by free fall. Free fall means an object falling under gravity. It may be dropped down. So for free fall, for a freely falling object, free fall, we consider acceleration is equal to 9.8 meter per second square. This is acceleration due to gravity. We can take A is equal to plus G. Okay, but usually we take A is equal to minus G. This is a negative that we will choose. It is constant acceleration. So in this case, U will be 0. Why? It is freely falling, initial velocity will be 0. This is called a free fall. While doing problems for upward motion, when you throw an object upwards, we can take acceleration minus G, and downward motion we can use A is equal to plus G. But usually, actually the concept is that acceleration is always taken as negative for a freely falling object. Okay, using this we can draw a few graphs. First we will draw an acceleration time. Acceleration is negative. So we will draw an acceleration time graph. Acceleration, and this is time. Acceleration is constant. So we will draw a horizontal line like this. A horizontal line, because this is the value of acceleration. What is the value of acceleration? Minus G. This is origin, minus G is the value of acceleration. Okay. Then we have position time graph. This is position and this is time. How will you draw position time graph? We have S is equal to, or X is equal to U is 0, half A T square. But A is negative. So X is equal to minus 1 by 2 G into T square. So X proportional to T square. We will get a parabolic shape like this. X is negative because minus half is there. So we have a parabolic shape. Now what about the velocity time graph for the same motion? For the free falling motion, 0, we have velocity time graph. What is the equation of velocity? V is equal to U plus AT. So V is equal to U is 0. V is equal to AT. A is equal to minus G. So V is equal to minus GT. So it is V proportional to T. Directly proportional, we should get a straight line graph. But it is negative because velocity is negative. So since the velocity, position and acceleration are negative, I have chosen the negative y-axis for position. Okay. Here what we can write? X proportional to, here X proportional to T square minus T square. That's why I have chosen minus axis. Then T square, X proportional to T square, we have a parabolic shape. Here velocity proportional to minus T. So proportional to T. That's why I have chosen a straight line. Directly proportional to T indicates straight line graph. Proportional to T square, we have a parabolic shape. So we have covered a few topics from motion in a straight line. Initially, we have seen position time graph, velocity time graph, an important relation, that is a relation for distance traveled by a body in n per second. Then we have seen what is meant by relative velocity, and at last we have seen free fall. Okay, I hope that you have understood. Thank you.